In this video, we're going to continue working with the lowest common multiple, or LCM, and we're going to use it to combine some slightly more complicated fractions. Supposing we needed to combine 2/15ths with 2/5. Well, what we'd want to find out is what's the biggest number into which both 15 and 5 evenly divide. And to do that, we're going to want to prime factor both 15 and 5. So the prime numbers, the first of the prime numbers, 2, 3, 5, 7, 11, and so on. We generally will get all the mileage we need out of just the first 5. Now, let's see, does 2 go into 15? No, not evenly. Will 3 go into 15? Well, I believe so. When we factor a 3 into 15, 3 goes into 15 5 times. So 15 prime factors into a 3 and a 5. And as for 5, well, that's already a prime number. It's the third of our prime numbers. So we don't have to factor that at all. Now, to get the lowest common multiple, we take each of our prime factors in its biggest appearance. The biggest appearance of 3 in either of these is right here. It appears once, so that'll give us a 3. And the biggest appearance of 5, it appears once here and once here, but in either case, it never appears more than once in either one of the numbers. It appears once to help make up 5, it appears once to help make 15. So the biggest appearance of 5 is only 5. And when everybody does their best, you get the very least. The best 3 could do in either numbers was appear once. The best 3 could do in either of the numbers was appear once. So that would be 3. The best that 5 could do was to appear once, which gives us a 5. And when everybody does their best, you get the very least common multiple, and 3 times 5 equals 15. Now, we want to combine 2/15ths plus 2/5ths. Well, 2/15ths is already in the right form, 2/15ths. And we want to combine this with 2/5ths. Now, 3 times 5 will give us 15, so to get a 15 in the denominator, we're going to multiply that by 3. And the only way we're allowed to multiply the denominator by 3 is if we multiply the numerator by 3 as well. Because when we multiply any fraction by something which is the equivalent of 1, we change the form but not the value. So when we multiply across, we get 2 times 3, which equals 6. And in the denominator, we got 5 times 3, which is 15. So we've got 6/15ths. And 6/15ths really is the same as 2/5ths. It's just, if you factored out the 3, you'd end up with a 2 here. And if you factored out a 3 from the denominator, you'd get a 5 there. So now to combine, we've got 2/15ths and we want to add that to 6/15ths. Well, 2 plus 6 is equal to 8, and these are both 15ths, so it's 8/15ths. And there's our answer. Let's take another example. Supposing I wanted to combine 7/8 and 1/6. Well, I'd start by prime factoring the 8, and the smallest prime which goes into 8 is a 2. 2 goes into 8 4 times, and I can prime factor that as well. That same smallest prime number, 2, factors into 4 twice. So now we've completely factored it. We've got nothing but primes. So 8 factors into 2 times 2 times 2, and 6 can be prime factored. Well, 2 will go into 6. because 2 will go into any even number. As soon as I saw that 8 was an even number, I knew that 2 would work. And the same is so of 6. I factor a 2 into that, and 2 goes into 6 3 times, and I'm down to just primes. So 6 is made up of 2 times 3. Now we want the biggest appearance of each of our prime factors. The biggest appearance of 2 is up here in 8, in which it appears 3 times. That's 2 to the third power, 2 times 2 times 2. Now 2 does appear here as well, down as a component of 6, but we're only interested in the biggest appearance of each prime factor. And the biggest appearance of 2 is up here, where it's 2 times 2 times 2. And the biggest appearance of 3 is right here, where it's nothing but 3. Now, 2 times 2 times 2, or 2 cubed, is equal to 8. And 3 is, well, that's already in the biggest form it's going to be in, so that just stays as it is. So we know that to get the very least, we multiply the 2 very best appearances we got of each prime factor, and that's 8 times 3, which is equal to 24. Now, to combine 7/8 plus 1/6, we want to get 24 in the numerator and the denominator. Well, how do I turn an 8 into a 24? Well, we can see from here that if we multiply 8 by 3, it turns into 24. So let's multiply this by 3, and what we do downstairs, we do upstairs as well. So we multiply it by 3/3, or 1, and so that'll give us the denominator we want, changing the form, but not the value of the expression 7/8. Now, to turn 1/6 into something over 24, we're going to multiply that by a fraction as well. Now, you probably can tell just, well, without even thinking that you can probably tell right away that to turn 6 into 24, all you've got to do is multiply it by 4. But if we have a situation where it's not quite so simple, here's the way of getting your answer fast. We saw that all the prime factors that gave us 24 were 2 times 2 times 2 times 3. 6 is accounted for by the 2 times 3. Whatever is not accounted for by the number itself, that's what we're going to multiply it by. So if we multiply the 2 times 3, the 6, by 2 times 2, or 4, we're going to get the 24 we want. Okay, if we're going to multiply the denominator by 4, we do the same to the numerator. So we multiply the 1/6 by 4/4. Now, 3 times 7 will give us 21/8. And we're going to add this to 1 time, Now, 3 times 7 will give us 21, and Now, 3 times 7 will give us 21, and in the denominator 3 times 8 will give us the 24 we wanted. And in the next part of our equation, 1 times 4 will give us a 4, and in the denominator we'll have 6 times 4, or 24, which is what we wanted. Now that we have the same denominator, the 24, we can perform the simple addition. 21 plus 4 is 25, and 25/24 is our answer.